All right, thank you guys for coming. We are going to talk about advanced async in Redux. So who's this guy? My name is Freddy Rangel. I really don't care how you pronounce my last name. I think we should mispronounce everyone's last names equally. But whatever, just get Freddy right. I hate Fred. I'm a senior software engineer at a company called HelloSign. We do e-signatures, document signing in the browser. So you can think of us as like a competitor to like DocuSign if you're familiar with them. Basically, we focus more on like the API and that sort of stuff. So we're kind of like the Stripe or the Twilio of the e-signature space. So I wrote a book about a year and a half ago, almost 2 years at this point, called React Under the Hood, A Beginner's Guide. And the funny thing about writing a book about the internals of a library is that the internals change a lot. So I ended up having to do too many updates to the book, and I just got sick of it. So I kind of deprecated it at this point. I mean, I still think it's a good introduction to React, but at this point, I'm not really maintaining it. So there's that. But I am working on a new book called Hacking in Front of Interview. Very clickbaity title, but so it's going to be about JavaScript interviews in front of interviews in general. I'm actually giving a workshop on that on Saturday, I think. So if you guys want to check out that workshop, will be a prelude to the actual book. So I've done some contributions to open source projects. I've done a little bit to like React and Redux and that sort of stuff. So I'm like familiar with the internals, but I mean, React is really massive. So I'm not like an expert on like the entire architecture. I'm not sure if anyone actually is. If they are, that would be really, really impressive. So cool. Out of curiosity, who was, so I gave a workshop on this yesterday. Who was here for that workshop yesterday? Yeah? Okay, you needed more. You needed more async in Redux. So. Oh, okay, yeah, gotcha. Or Monday, yeah, so you're on the Monday one. Gotcha. Cool. And if you want to know more about me for whatever reason, I'm a pretty boring dude, but sometimes I rant on Twitter. Just follow me on Twitter or Google me or whatever. So if I totally bore you to death and you only take one thing from this workshop, basically what I want you to know, or what I would assert, is that we've basically figured out how to structure the UI. And I'll go into that in a minute. But the thing that we're still trying to figure out as far as like front-end JavaScript goes is how do we do async? There are many different solutions. You could do Thunks, promises, observables, generators, other patterns like CSP channels, that sort of stuff, which is a little advanced, and JS CSP is not actually well-maintained these days. But there are a lot of different approaches you could take, and so I want to give you guys like the pros and cons of the different approaches that you can do in your applications. So I want to give you guys like a big overview of where JavaScript is. And I would assert that what's been happening in the last decade is something of like a JavaScript Cambrian explosion. And if you're familiar with like the Cambrian, so I'm a nerd of like history and like that sort of stuff. So the Cambrian explosion was a period when there was like a massive explosion of from like single cell organisms to like a lot of like complex animal life. And if you like watch a documentary and that stuff, there's a lot of interesting types of animals that seem like they're really alien and didn't survive, right? So that's kind of what happened in JavaScript, where JavaScript engines became a lot more powerful, and now people started experimenting stuff in the front end. And so we've been experimenting with stuff like, say, like Knockout, stuff that really didn't survive very well. So like I know in my career, I ended up having to learn like jQuery, Marionette, Knockout, Backbone, Angular 1, Angular 2, Ember 1, Ember 2, and then what about build systems, right? There's Gulp, Grunt, Webpack. The list just goes on and on of like the stuff that's been changing on the front end. But I would say that that's actually a good thing. What's happening is we're just seeing like an explosion of different experiments, and we're slowly starting to solidify around like certain solutions and certain libraries and that sort of stuff. So we're starting to see a little bit of a slowdown, and I think we're going to see a slowdown in the next decade. But this overall is a good thing. This just means that front-end JavaScript is really exploding, and it's maturing slowly. So I would say that as far as like structuring a UI, we basically figured that out. We know that we don't want jQuery spaghetti all over the place. And we've tried like different approaches, but when React was open sourced 4 years ago and really caught on like 2.5 years ago, we really started seeing a really great way for structuring the UI in a component-based way with unidirectional data flow. But that's cool, but it's still not a full architecture. There's still stuff that's missing from it. You typically don't want to put all your business logic within your React components. You want to try to separate concerns. So, I mean, you could put all your business logic in React, but it complex stuff and it becomes difficult to figure out what's happening over time. So one solution was with Facebook and the Flux pattern for state management. And that's cool, a little confusing. There's a lot of like dispatchers and a lot of like stores and that sort of stuff. And it's kind of hard to like wrap your head around it. And I'm not sure if Facebook is still doing this. I'm not sure. If anyone like works at Facebook here and they work on like the front-end JavaScript side, I would like to know. I'm really curious. But I would say that as far as like the different types of Flux implementations, Redux has basically won. And for a couple reasons. I think that, they took a lot of inspiration out of the Elm architecture, which is pretty awesome. If you are not familiar with Elm, I would recommend you take a look at it. And there's an excellent book that I would recommend you take a look by Richard Feldman. Pretty awesome. And so what I like about Redux is that you manage state with pure functions, which is really nice. It has a unidirectional data flow similar to React, so you keep the same paradigm across your entire architecture. It helps remove business logic out of your React views. And it's really, really small. It's only like 300 lines of code. So you can look through it over a weekend and figure out what Redux is doing. It's not a massive library. I think actually when you inspect the code with like Webpack Visualizer, it looks a lot better than it is because it's very well documented. So once it's run through Uglify, then it's going to be a lot smaller than it is because it's really only 300 lines of code. Some of the cons, though, is that so Redux is a workflow. It's not a complete architecture. There's no story for like async. There's no out-of-the-box story for routing, that sort of stuff. And I think that's my biggest complaint these days about Redux is Redux and routing, right? Because on one place you have your application state in the Redux store, but the URL is also state, right? So like you have it like spread across two different places, and like how do you manage that stuff? It feels kind of clunky, right? Like you have React router, and that's okay. I'm okay with it. But figuring out like how to unify that is something I'm still trying to figure out these days. So you still have to build an architecture on top of React, on top of Redux, right? You still need a solution for routing, for async, for that sort of stuff. Well, the good news is Redux has a way to do that via middleware. So I'm going to talk about middleware in Redux. Who here has written their own middleware for Redux? One. Oh, more than I thought. All right, cool. There's like 10 people. Okay, cool. Superstars. Awesome. Okay, so a brief overview of Redux middleware. So it's basically a third-party extension that allows you to customize a dispatch method. So you can do things like log actions in state to the console, that sort of stuff, or deal with asynchronous operations. So essentially, what Redux middleware does is it uses currying to create like custom dispatch methods, and this middleware is essentially like a chain of middleware functions, and we'll go through like what that actually looks like. So this is actually really close to the logger middleware that we have at HelloSign, and one thing you'll definitely notice at the top, but we don't want to do logging in production. Right? So we want to check if the node env is not production. If it's not, then we're going to do our actual logging. And at first, this might give you like heart palpitations, like what is like store, what is next, what is action, like why are things happening? And it's actually not that bad, like especially once it's explained to you. Okay, so at the very top, we have essentially a function that returns another function that returns another function. And the reason why it works this way is a little complicated, and I think Dan Abramoff does it a lot more justice than I could within 40 minutes. I think it's in the Redux documentation. I would encourage you to take a look at why it's structured this way. But doing it this way avoids like monkey patching the actual dispatch method for Redux. So the very first thing you'll notice is that we have a function that expects a store. It's not the actual Redux store. It is like the methods you would expect that a Redux store would have, like dispatch and get state, but you don't have like a subscribe method. You only have dispatch and get state. That then returns another function that expects a next argument. And I think that's the part that's actually most confusing is that next argument is the next middleware in the chain. So you could call it like next middleware or something like that. That's definitely the part that like confused me the most. Because the middleware is like chained together, you need to be able to tell Redux, hey, this middleware is done. Now I need to pass the action down the chain to the next middleware, right? And then finally, that returns another function that takes the actual action that's been dispatched to the store. So it's very crucial when you're writing Redux middleware to always do next action. Always. You have to do this. If you don't do this, the action is going to be lost in the ether, and then your application is going to break. So you have to pass action to the next middleware. Otherwise, it's not actually going to reach the next middleware, and it's never going to reach the Redux store. That's basically the gist of what you need to know. But within here, we could do some interesting stuff. Like we can log the action that's been dispatched. And we can also log the current state of the application. And I use this like multiple times a day. Like this has been like really, really useful for debugging purposes on my end. Okay. So why would you want to do async via middleware? There are different ways you could do async outside of Redux. But what I like about this approach is that you can watch for certain actions within your current architecture and then do interesting things like async that fits really well with Redux and React already. You could try to like hook in outside of it, but it can be like a little awkward. And I just like the whole unified approach of using middleware for doing asynchronous operations. So there are quite a few flavors of async middleware. And they all have pros and cons. Some of them I like more than others. And I just want to give you guys like all, the plethora of different flavors of async middleware that you can use in your applications. So the big one is Redux Funk. Who uses Redux Funk? Okay, that's like everybody. Okay, cool. Redux Funk is fine. I'm going to try to convince you, one, to remove that node module, like today. After we actually look at the source code, you're going to remove that node module. You don't need it. And two, I would encourage you to think about moving away from Redux Funk. But there's still a lot of pros of Redux Funk, so you don't necessarily have to move away from it. So I'll just give you my opinions on the library itself. So the documentation, it recommends Redux Funk, and I think that is a good thing. It's very, very simple. So trying to introduce someone to Redux and then telling them, oh, by the way, now you have to learn generators for Redux Saga, that's a little too much for people, in my opinion. So normally when you dispatch something to the store, you dispatch an action, right? And an action is an object. But Redux Funk allows you to dispatch a function to the store. And Redux Funk middleware it's going to assume that if the thing that's been dispatched is a function, then it's going to be a thunk. So you want to pass in certain arguments to that thunk. So what Redux Funk is basically going to do is it's going to pass the store to that thunk. And that store has two arguments, or two methods, the dispatch and get state. So what is a thunk, actually? At first, I thought it was a made-up word. It's not. There's like a Wikipedia article page for it. It's like a real computer science thing. This, just to give you an idea, so this is immediately evaluated, right? X is immediately assigned 3. I can do math. However, in this function, 1 plus 2 is not executed. Right? We're delaying the execution for another time. We actually have to call foo in order to execute this expression. So you can think of like async stuff within a thunk to be delayed later, which is going to be called by the Redux Funk middleware. So these are two action creators, and one of them returns a regular action, and the other one returns a thunk. So this should be fairly familiar to you guys. This returns an action. But this one here returns a thunk. And this thunk expects two things. It expects dispatch as the first argument and get state as the second argument. And then you could do things like, say you needed the user ID to be able to pull user data from the store, right? You want to be able to call get state to be able to grab that user data. And then afterwards, of course, you want to be able to dispatch actions. Say you pull data from the server, you want to be able to dispatch that data to the store to do interesting things with it. So really, really simple. That's basically all you need to know about implementing Redux Funk. But let's look at the actual source code. All right, you guys ready? All right, that's it. It's 4 lines of code. So read your node modules. See what's in them. So actually, if you look at the source code for Redux Funk, there's about 7 lines of code. So this is a little more simplified. But yeah, that is about it. So let me walk you through exactly what it's doing. At the very top, we have a function that just checks if an action is a function. That's all it does, right? And so this part I already explained. We're basically deconstructing a store, grabbing dispatch and get state from that store. And then this line just checks if the action is a function. If it is, then we're going to pass dispatch and get state to that action. It's going to assume that it's a thunk. So it's going to call the thunk, because it's a function, right? So it's going to call a thunk with dispatch and get state, and then your thunk will be executed with all your async stuff within it. Otherwise, it's just going to totally ignore it. It's going to pass that action to the next state. That's it. That's all. Delete Redux thunk. Do this. OK. So some of the pros, it's a really simple extraction. I mean, this is 4 lines of code, right? You really don't need a library. You could just totally write this yourself. And it works really well for like small projects. So if I were to do like a greenfield project right now, I'd probably end up starting with Redux Funk because I don't know if I'm going to need something as robust as like RxJS or Redux Saga, that sort of stuff. This is fairly straightforward and it's really small, and I don't need to import like a larger library to do this. Some of the cons, though, is that it doesn't really scale very well as a project scales. So this is a problem that I started seeing at HelloSign, where it was very hard to figure out where all my async stuff was going. I had to jump through like 10 different files to find out, okay, where am I actually calling this HTTP library? And like it just got a little confusing. So it spreads async logic across different parts of your application. It's hard to figure out where all that stuff is happening. It's also not FSA compliant. And what FSA is, it's Flux Standard Action. So it defines it's basically like a spec that defines what an action should look like, right? So it's not an accident that actions have a type property, right, and a payload property typically. That's actually like a standard that these libraries try to emulate. There's also no way to cancel a thunk, right? So once that thunk is executed, or once that thunk is called, it's gone. It's lost in the ether. You can't really cancel it. So one problem would be, say you have like this is a bug from the workshop from yesterday, which is if you have a button that calls some kind of asynchronous operation, like it pulls like image URLs from a particular API or something. If you hit that button and make the asynchronous call like 1,000,000 times, right? Say your code at the very end of it grabs that URL, and then it dispatches that to the store, and then you add a new image, right? So what happens if you have like concurrent HTTP calls that are happening simultaneously? Like you don't want those previous thunks to actually add those images to the DOM, right? So there's a couple ways you can mitigate that. Like obviously you want to like debounce and that sort of stuff, but ideally you want to be able to tell your middleware, hey, only take the very latest one, right? But this is also true for like forms, that sort of stuff. So once a thunk has been dispatched, you can't do anything with it. It's also not very good for handling streams of data. So I still haven't seen an implementation that used like a WebSocket with thunks, and I don't want to. That looks really, really horrible, or it sounds horrible. Okay, Promise middleware. Promise middleware is very similar to Thunk middleware. The internals are exactly the same, and I don't want to waste your time with like showing you that code because it's a little hairier, and it actually does the exact same thing. Basically, it's going to check if it's a promise, and if it is a promise, and it's going to resolve that promise for you, and then just do things from there. Very, very similar. It has the same pros and cons for the most part, except that promises are built for async, right? And thunks, not really. So I would still say that go with Redux Thunk, but if you really want to go with like being able to dispatch promises to the store, then I would go with Redux Thunk middleware. It's like it has like the best conventions. I think there's like 3 of them out there. There's like Redux Promise, there's Redux Promise middleware, and then there's like another one. And I think Redux Promise middleware is probably like one of the best of those 3, in my opinion. So anyone use like Redux Promise middleware or Redux or like promises for async stuff in Redux? No? Okay. Yes, we have one person. Oh, okay. Say again?
Redux Actions.
Redux Actions? Okay. That's one I haven't heard of. Yeah, I'll take a look at that one later. Oh, okay, gotcha. Okay, so let's talk about observables and RxJS. It's kind of like the elephant in the room when it comes to observables in JavaScript. And who's a fan of RxJS? Out of curiosity. Okay, I'm gonna troll all you guys. You guys are gonna hate me. I am not a fan. I really dislike RxJS with a passion. However, I respect people who are fans of RxJS. And the reason is because I know a lot of intelligent people who are huge fans of RxJS. And I think that's the problem. I think that you have to be too smart to understand it, in my opinion. Like the API is massive. Like even looking at one module, there's like 50 methods to it, right? It's massive. So, and I think the reason why it's so big is it's trying to put something in JavaScript that's not there, which is observables, right? So over time, it keeps growing and growing and growing. And it's giving me flashbacks to like Ember. I don't like it. But that being said, though, you know, Netflix is using it pretty heavily, and a lot of companies are using it. So that's my own personal opinion. But I would take a look at it yourself and form your own opinion. I could totally be wrong. I could be very, very wrong. But that's my own personal opinion now. However, I would say, and I think most of you would probably agree with me, it's a little clunky to use with Redux. So I would, or at least through Redux middleware. Like I've seen certain implementations that were like just really, really clunky to do. And so it just didn't seem worth it. Like I would use like RxJS like outside of Redux and figure out your architecture slightly differently. Okay, so we're going to talk about generators and Redux Saga. And I've been using Redux Saga for about a year at this point, like professionally. So I'm pretty confident that I can't think of anyone else who's used it longer than I have at this point. Yeah. So we've been using it in production for nearly a year at HelloSign. And it's been pretty awesome for us for a couple reasons. One, it's based on generators. That's in the language. So you don't have to like rely on some kind of DSL to do this. It's a Redux implementation of the Saga pattern, which I'll get into in a second. And so instead of dispatching Thunks, we are creating Sagas that gather all your side effects into one place. So now what you have is you have another pillar of your architecture. You have React for your UI. You have Redux and reducers for updating application state. And you have Sagas for all your async stuff. So you can find all your async stuff in one place. You almost have like a reducer for your async operations. So it cleans up a lot of stuff, and it's pretty awesome. The Saga pattern, so it's based off of a paper, I think, published in the late 80s out of MIT. I forget the two people who were co-authors for that. But it's essentially a failure management pattern. And so I think that like most programmers and most engineers, like we like to think of the happy path for stuff, right? Like I like the fact that the Saga pattern thinks about what can go wrong and how do we handle failure, right? Like how do we make sure that our system is not going to crash, right? So with Sagas, basically, it's all about managing failure and having strategies around like, okay, if there's a failure, do we want to roll forward or roll back? That's essentially like the two concepts in the Saga pattern, like roll forward or roll back. So the prototypical example is, say you have a travel service that does three things, right? It books your flight, it rents a car, and then books a hotel. So what happens if you're booking your flight and that fails? Chances are you probably don't want to rent a car, and you don't want to book the hotel because you're not going to be there, right? So, okay, so we're going to want to roll back. But, okay, what happens if that succeeds and then you try to book or you try to rent a car and that fails, right? Chances are, well, you're already there. You could take a Lyft. Did you guys see there? I did not say the other company. Yeah, so you could take a Lyft, or you could take a taxi, or you could just walk. Yeah. So there are options, right? There are options. So otherwise, you're going to roll forward, right? You're going to fail forward. And if you can't book a hotel, then chances are you probably should roll the entire thing back, right? You should roll back the renting of the car, and you should roll back your flight because where are you going to sleep, right? So that's kind of like how you want to think about Sagas. It's just like another way to think, really. So this is the example from the Redux Saga documentation. And some of this, I'm not going to explain all of it. I actually just did a workshop on it, so I could literally talk about this stuff all day. But I'm just going to briefly go through like what this is. Who here's familiar with generators? Like most people. All right, cool. That's awesome. Okay. So this generator is a Saga, and this generator is only concerned about fetching a user. So what I like about this approach is that it's very explicit about errors, right? Like as opposed to promises where it's very easy to forget, like to put a .catch. It's like an afterthought. Here you have to consciously ignore handling errors, right? So there are cases where there's an error, and I know that we don't have to really do anything there. Like we don't have to really tell the user because it's something internal. But for the most part, there have been places where, actually, what happens if we try to pull data from the server and it doesn't return? I could talk to my product manager and say, hey, maybe I need some kind of mock-up for like an error page or that sort of stuff, right? So you're forced to think about errors. Okay, so within the try block, we are doing two things. We are yielding this call method, this call function. And so you don't actually have to do that. If you yield a promise, then the Redux Saga middleware will resolve that promise for you and return it. However, that makes it very difficult to test, right? Because then that promise is actually going to be called in a test, and then you have to like mock out or stub whatever HTTP library you're using or whatever. So that could be an issue. However, Redux Saga gives you call, which is essentially an object that describes instructions to the middleware. So it's basically just an object with like the function and then the arguments for that function. So call, the first argument to call is the function you actually want to call. And then all the rest of the arguments are arguments that are going to go to that function. So in your test, all you need to do is test that call returns an object that has that function and then the arguments that are supposed to be passed into it. It's just instructions. So you don't have to stub anything. You don't have to mock anything. It actually doesn't get called until it reaches the middleware. But in the test, if you're just pulling that generator and testing it there, it's not actually being called. So the second line there, yield put. So put is a lot like dispatch, except instead of actually dispatching to the store, it's also an effect, which is like an object of instructions to the middleware. So that way you don't have to set up like a fake store and that sort of stuff and try to test that something's been dispatched, that sort of stuff. Now all you need to do is test that put has been called with the proper action. Pretty straightforward. And then here we're dealing with an error state. We're just going to dispatch the error to the Redux store. And then from the store, we can do things like notify the user that things have gone wrong or whatever. OK, so this is what you could consider your root Saga. And what we're basically doing is we're yielding take every. And what take every will do is, well, it takes at a bare minimum 2 arguments. The very first one is the name of the type of action that you want to respond to. So every time Redux Saga comes across user fetch requested, every time that's been dispatched to the to the store, we're going to call the fetch user generator. That's essentially what it's going to do. So every single time it comes across the action, it's going to do fetch user. But maybe you don't want to do that, right? Maybe a user's like clicking stuff like too often, right? So maybe you only want to take the latest one. And that's what this helper method does. So what it's going to do is it's going to keep a buffer of all the concurrent API calls or the concurrent asynchronous operations. And it's only going to keep the latest ones. So it's going to cancel all the prior ones. Now, of course, you can't cancel HTTP, but you can cancel what happens afterwards, right? So if we go up here, say like call API fetch user, that's still happening, right? If you cancel it while it's still doing its thing, okay, it's going to get the data, but it's not going to do anything with it. It's not going to call .next on this generator, and when you call .next, that's when the actual putting to the store happens. So yes, it's going to pull the data, but it's not going to do anything with it if it's canceled, which is probably what you want. Unless, of course, it's a post request. If it's a post request, then you might want to handle each one of them, but it really depends on your particular use case, and it's really up to you. So the pros is that it takes async into basically a pillar of your architecture. You can write async code that looks asynchronous, and you're very explicit about like error states, failure states, that sort of stuff. Generators are part of the language, which is one of the pluses of generators. And for testing, you don't need to do any dependency injection or mocking or stuffing or anything like that. Some of the cons is that most of the tutorials out there for generators are terrible. Terrible. I don't know why. There's a really good book on generators called The 80-20 of Generators. Awesome book. One of the best books I've read in a while. I wish my book was that good. It's just really, really good. I mean, he walks you through how to transpile generators into ES5 code. So you basically create your own Babel, right? So in the process, you end up learning how like Babel works internally, which is really cool. Okay, the internals are like a little complicated, but it's not too bad. Like my job is to become an expert in this stuff, so I have to read the internals, but you don't. So I wouldn't worry about that too much. And if you're supporting older browsers, so we support IE8. Yeah, that's my life. It sucks. So we support IE8, and this is like an issue for us. We can't just focus on evergreen browsers. So that's an issue. But if you don't really care, then I think everything other than Safari supports generators at this point. I might be wrong about that. I don't know. But still, most likely you'll have to import like a Babel polyfill or some other generator runtime. So there are a lot of different options for async in Redux. Right now, I would look at Redux Saga if you want a really robust solution, my personal opinion. And if you really want something simple, then Redux Funk is still cool. You can still use it. It still works just fine. Okay, and that's it. Thank you very much. And stay tuned for the book that I'm probably going to finish maybe in the next 4 to 6 months. I don't know. Writing books is hard. And yeah, follow me on Twitter if you want. And yeah, that's my GitHub there. So, all right. Thanks.